Hello students, in today's session let's learn about rectifiers and bridge rectifiers. Everybody would have heard about rectifiers, so tell what is meant by a rectifier. Diodes are very commonly used for obtaining DC voltage supplies from the readily available AC voltage. A rectifier is a device which is used to convert an alternating current which periodically reverses the direction into a direct one which flows only in one direction, and this process is called rectification. This is the most popular application of diode in power supplies. Diode rectifiers rely on diodes for their operation. Diodes are devices that only passes current in one direction. As we know, the diode has a characteristic, something like that shown in this figure. In the forward direction, a small voltage is required across the diode before it conducts, which is the turn-on voltage. The actual voltage depends on the type of diode rectifier and the material used. For a standard silicon diode rectifier, this turn-on voltage is around 0.6 volt, and for germanium it is around 0.3 volts. In the reverse direction, the diode rectifier will ultimately break down. This is a property of the diode what we are using in rectifiers. Rectifiers are used in various devices including DC power supplies, radio signals and detectors as a source of power instead of generating current, as flame rectification to detect the presence of flame, high power direct current power transmission systems. Several household appliances use power rectifiers to create power like notebooks or laptops, video game systems and televisions. There are many possible ways to construct rectifier circuits using diodes. The three basic types of rectifier circuits are: the first one is a half-wave rectifier, the second one is full-wave rectifier, and the last one is a bridge rectifier. Now let's have a look at bridge rectifier. In many power supply circuits, the bridge rectifier is used. The figure shows the circuit of a bridge rectifier. The full-wave bridge rectifier uses 4 diodes arranged in a bridge circuit to give full-wave rectification without the need for a center tap transformer. This bridge is connected to the secondary of the transformer. The bridge rectifier can be built from separate diodes, or a combined bridge rectifier can be used. The input waveform is given by a sinusoidal wave like this. For the study purpose, we are considering the diodes as ideal. In a basic power supply, the input power transformer has its primary winding connected to the main supply, and in this case a step-down transformer is used to reduce the voltage level of the input. Let's go through the working of the bridge rectifier. During the positive half cycle of the input waveform, the upper terminal of the transformer secondary will be positive with respect to the lower terminal of the transformer secondary. Because of the positive voltage applied to the upper terminal of the transformer secondary, which will be connected to the P side of the diodes D1 and D3, and the negative voltage which is given in the lower terminal, that will be connected to the N side of the diodes D1 and D3. The diodes D1 and D3 are forward biased and it will operate as a closed switch. Similarly, because of the positive voltage applied to the N side of the diodes D2 and D4 and the negative voltage applied to the P side, the diodes D2 and D4 are reverse biased and it will conduct. So now during the positive half cycle of the input waveform, the diodes D1 and D3 are forward biased and diodes D2 and D4 are reverse biased. So the current will flow from point A through the diode D1 to point B, reaches a load resistor RL and moves to point D, and through the diode D3 to the point C and reaches the lower terminal of the transformer secondary. So the direction of current flow is given by this figure. So now we got an output voltage across a resistor RL with polarity in the positive side. During the negative half cycle of the input waveform, the upper terminal of the transformer secondary will be negative with respect to the lower terminal of the secondary of the transformer. Because of the negative voltage applied to the upper terminal of the transformer secondary, which will be connected to the P side of the diodes D1 and D3, and the positive voltage which is given in the lower terminal, that will be connected to the N side of the diodes D1 and D3, the diodes D1 and D3 are reverse biased and it will operate as an open switch, and diodes D1 and D3 will not conduct. Similarly, because of the negative voltage applied to the inside of the diodes D2 and D4 and the positive voltage applied to the P side, the diodes D2 and D4 are forward biased. So now diodes D2 and D4 acts as a closed switch and it will conduct. So during the negative half cycle of the input waveform, the diodes D1 and D3 are reverse biased and diodes D2 and D4 are forward biased. So the current will flow from point C through the diode D2 to point B, reaches the load resistor RL and moves to point D and through the diode D4 to the point A and then reaches the upper terminal of the transformer secondary. So the direction of current flow is given by this figure. So during the negative half cycle of the input also we got an output which is of positive polarity. It can be seen that on each half cycle opposite pairs of diodes conduct, but the current through the load remains in the same polarity for both half cycles. This figure shows the input and the output waveforms. The advantage of using this circuit is that no center tap transformer is required. An additional advantage is that as two diodes are conducting at one time, the diodes need only half of the reverse breakdown voltage capability of diodes used for half and conventional full wave rectification. The bridge rectifier produces almost double the output voltage as a full wave center tap transformer rectifier using the same secondary voltage. So in today's session we have gone through rectifiers and bridge rectifiers, which is a type of full wave rectifier. Hope you have got a good insight on the same. Until we meet again, bye.